All right, if you've ever tried to build a machine learning model, you absolutely know the struggle, right? You've got this messy notebook that works, kinda, but how do you get from that to clean, professional, production-ready code? Well, today we're going to unlock the secret to doing exactly that with one of Scikit-learn's most powerful but maybe underappreciated tools, the pipeline. But hang on, before we start building, we have to talk about a hidden danger. I want you to ask yourself this question. Is your model secretly cheating? I know, it sounds super dramatic, but this is the real reason so many models look fantastic in a notebook and then just completely fall apart in the real world. And the culprit has a name: data leakage. So where does this, cheating actually come from? Well, it happens when we do things the manual way. And look, it seems totally logical, right? You take your whole data set, you scale it, then you split it up for testing and cross-validation. But that is the trap. The pipeline way, on the other hand, bundles every single step together, and that creates this protective shield that makes leakage pretty much impossible. And that trap, that's data leakage. Think of it like this. It's when your model gets a sneak peek at the test questions before the exam. For instance, when you scale your entire dataset before you split it, your training data is learning things about the validation data it should have never seen. This gives your model a totally unfair advantage, and it leads to these amazing performance scores that are, unfortunately, completely fake. So, the solution to this whole tangled mess is actually beautifully simple. It's the Scikit-learn pipeline. Instead of trying to juggle all these separate steps, scaling here, encoding there, fitting the model, the pipeline organizes everything into one clean, straight-line process. It basically turns chaos into order. So how do we actually do this? We're going to follow a simple 5-step game plan. First, we'll split the data. Then we build the pipeline. After that, we'll cross-validate it the safe way. Then we tune it to get the best performance, and finally, we deploy our finished model. Okay, let's get to it. Okay, step 1. Real-world data is always a mess, right? It's a mix of numbers, categories, all sorts of stuff. So our first tool here is the column transformer. You can think of it like a smart dispatcher at a factory. It looks at all the messy data coming in and automatically sends each column to exactly the right processing station. And here's how that column transformer works its magic. We just tell it what to do with what. We say, hey, for all the number columns, use a standard scaler. And for all the category columns, use a one-hot encoder. That's it. It handles everything in parallel, automatically. No more slicing and dicing your data by hand. It's clean, it's organized, and it gets rid of a huge source of potential bugs right from the start. Now that we have our preprocessor built, we can assemble the full pipeline. And it's so simple. We just create a list of steps. Step 1, our preprocessor. Step 2, our actual model, in this case, a random forest classifier. And just like that, poof, the two are changed together into one powerful unit. And this right here, this is where the leak-proof magic really happens. See, when you use this pipeline with something like cross-val score, Scikit-learn is incredibly smart. For each and every validation fold, it only fits the preprocessor on the training portion for that fold. It never, ever lets it see the validation data during fitting. This simple automatic behavior is what completely eliminates data leakage and guarantees your results are legit. But wait, there's more. The power of the pipeline doesn't stop there. We can tune the hyperparameters for the entire workflow all at once using grid search. And the key is the special, kind of funny-looking syntax with the double underscore. See where it says classifier-n estimators? That's not a typo. It's like giving an address. It tells the grid search, hey, go inside the pipeline, find the step I named classifier, and start tuning its n estimators parameter. It's such a clean way to optimize the whole system from end to end. And the results, well, they speak for themselves. Our baseline accuracy was hovering around 81.5%. But by tuning the pipeline, we pushed that up to a solid 83.5%. And that's a real validated improvement confirmed on data the model has never, ever seen before. This just proves that a well-structured pipeline isn't just about writing cleaner code, it's about building a fundamentally better, more effective model. Now, once the grid search VC is done running, it doesn't just give you the best parameters, it gives you something way more valuable, the best underscore estimator underscore. And what is that? That is the final, fully trained pipeline, automatically refit on all of your training data using those perfect settings it just found. It is your production-ready model all packaged up in a single convenient object. And here it is, the ultimate payoff, the whole reason we did this. When some new data comes in, you don't have to remember all the complex steps you did for preprocessing. You just call one single method, .predict. That final pipeline handles everything under the hood, the scaling, the encoding, the predicting, using the exact same logic it was trained with. It's safe, it's repeatable, and honestly, it's just beautifully simple. So let's just take a step back. We have replaced a complex, messy, error-prone workflow with a system that is safe, automated, and totally ready for production. By killing data leakage and organizing our code, we've built a single object that takes raw data and gives you a prediction in one clean step. So now, the only question left is, what are you going to build with this power?